I'm Tim Ventura from AmericanAntiGravity.com, and I'm speaking with Arie DeGeus, an independent inventor, scientist, and theoretician who's not only rewritten the book on nuclear and particle physics, but has also used his theory's predictive powers to build a startling array of innovative new technologies. Well, Arie, I'd like to start out by noting that you're in the unique position of playing a dual role as both an experimentalist and theoretician. Most researchers only do one or the other. Can you tell us a bit about the challenges and rewards involved with juggling both of these very demanding roles?
Tim, it's like this. You still need one other component to be complete. It's experimentation and theoretical understanding, but at the same time, all of that needs to be put into practice by building the designs which came up, to be created. And then when these designs work or do not work or work to certain degrees, that's the feedback for the further experimentation, and you compare it to the theories. Now, we have wound up, after quite a bit of time, that most of the things that we do, it used to be that in these areas of research where nobody has ever been yet, that you do maybe 10 things and you do 8, not exactly right the first time, but now we do 8 right out of 10, the first time basically when we go into it. So that is has been a learning curve, really. The theory is to us a proven thing because the things that we do based on that theory all the time work. So that's how it's been. And challenges, there are plenty of challenges. The biggest challenge is having enough time in life. I mean, I could work 48 hours in a day if there were so many hours, in a day. There's very much to do. And also the number of people to work with is extremely limited due to the complexity of matters, and many times of outsiders who have not yet any open eye for the new physics and all of that. When they come in, they would say things that I actually have to juggle a little bit myself inside and think, well, this is conservative thinking according to the books that you've learned, but those things are not exactly correct.
Sure.
That's how it's been. But we're moving along, and I do have a friend. He's a local professor, one of the best, and he has also been astounded by how far we have come. And what we do is I do a little bit of sounding if new things are found, and sounding back and forward, just like a mirror. You know how that goes. And it's always good to do it like that. But we have gone a long way, and we have developed, I would say, more than a dozen technologies that are based on totally novel things, anywhere from nuclear transmutations to zero-point energy. And these things have good foundations theoretically, and all of them work. So we didn't have our head above the ground, so to speak, over the last years. Also in view of what happened to our friend Dr. Eugene Mallove and all that. And that might change a little bit now. So that's about, this earlier point that I can give you here. As far as public relations is concerned, about going public with a lot of knowledge that has been acquired, about which the general public would really be astounded. So we'll see how it develops and all, and the more easy things get as far as that, the more disclosure in general is being accepted, the more we are disclosing. It's that simple.
Yeah, absolutely. Well, I'll jump around a little bit in my questions here, because now that you've mentioned the Dr. late Eugene Mallove, I've been in contact with him also. We've done a couple of stories together for Infinite Energy magazine, and he'd repeatedly indicated a desire to me to showcase your research in the magazine, but at that time you weren't quite ready to take your research public.
Well, that's very simple to explain that. I run a little bit more than a garage operation, so to speak, and this company has been formed in the year 2000. Actually, we incorporated, and we spent a little bit more money just than single people would do normally. And stockholders have a right that there's some proprietary situation that things can be brought to fruition and become commercial, and that is still basically our standpoint. Although we have now many technologies that are so ready to be shown and ready to be commercial in the marketplace. Therefore, we can get more open about it. But that was basically a little bit because of proprietary reasons. That not everything would be told right away, where we paid lots of money to find it, that's simple, Tim.
Yeah. Well, and I think that's one of the reasons that I've been so excited about finally being able to interview you, is that in a way it follows through on his dream. So I'm happy to be able to try and continue that legacy just a little bit. But
you were asking me about the background and how I got started and all of this. You want me to explain some about that and all?
Yeah, please do.
It's quite long already. 1978, you remember that was sort of the tail end of the energy crisis here in the country when people, stood in line at the pub. And that was a very fertile period suddenly for alternative energy people, to come off the ground. Carter was in the presidency at that time, and James Schlesinger was the czar. You remember the term yet? The energy czar?
Sure.
All of that went easy in those days, and I got several federal grants from DOE and also state grants and all to develop fairly advanced things for that period, advanced types of solar with going in towards Stirling and certain other things. Some special mechanisms of wind energy were developed. As soon as the 80s came in here, there were no openings anymore for giveaways or financing at DOE and all. So basically, it slowed down. It slowed quite a bit down, but we never really stopped. The bigger things came in the 1990s when we started finding some results that we did early work on hydrogen. And that's how I got to know Gene finally. I think that went back as far as, probably 96, 7 or somewhere around that time. And the terminology fractional hydrogen, does that say anything to you, Tim?
Yeah, actually, it reminds me in some ways of the blacklight power, doesn't it?
Yeah, it does. Right, now that blacklight power, certainly. Randall Mills, I remember the day his patent came out, and I was with Gene in his office, and we were taking it off the wire as it was published. I was with him at that time because I had a totally different approach. And we did a little bit of work over there at Concord in it and all, and got some results, not very big time results, but I knew that we were running over Unity on what we were doing. And then I repeated it here, and we started to get a little bit of a laboratory in a place that friends actually owned. We didn't have to pay anything for that. Right now we own our own laboratory, we don't owe anything here. The company also is net free, but that was still on a very small scale. Then later on we learned a whole lot more about this, and we got some more funding behind it and all too. Fractional hydrogen development came before the plasma fusion, and let me tell you about it a little bit here, if I may. Fractional hydrogen is hydrogen whereby the electrons have come to a lower energy state than the ground state. Now, your regular physics folks will tell you that's not possible, but they do not understand what the elements lithium, beryllium, and boron can do. When you see the abundancy curve of those elements in the universe, then you notice that lithium 7.3 and lithium, beryllium 9.4 and boron 11.5, that abundancy is something like 10 to the power 9 to 10 to the power 11 times less than you could expect. You got very much hydrogen, of course, that's about 90% of all the universe. And there's still a lot of helium, and then suddenly it drops off to virtually nothing for the elements lithium, beryllium, and boron, and there has to be a reason for that.
Yeah.
I investigated that reason into very great detail, and answers are being found being close to us. The beryllium plays also a role in the particles that the sun throws out. We find a lot of beryllium in the moon dust. The moon missions have all told us that too. We have, for instance, a corona around the sun which has a temperature up to 1.5 million degrees. And that process in there, the readings on the spectra on it, and these spectra all correspond with energy levels of electrons, according to the Rydberg formula, that have lower energy states than the ground state. So we succeeded in doing this, Tim, and we harvested quite a bit of energy. Now, hydrogen has been a big part of my work over the last 3-4 years, and hydrogen is now everybody's play ball in that sense, that people talk about fuel cells. Of course, everybody is into fuel cells, but nobody's talking about where to get the hydrogen from, when you need it, and where you need it.
Yeah.
So if I were to drive out west across Nevada and Utah and all these places, that would be a little bit difficult on hydrogen. You would still need a tractor trailer size of a tank, on wheels behind you.
Sure.
And all these technologies, whether now it's millions, and also the tokamaks, that's even a lot worse, but the billions are being thrown away. These technologies are totally old-fashioned, and shouldn't even be looked at anymore in view of what has been achieved here.
Well, so it sounds like, from the way you're describing it, one of the things that really was kind of a tip-off was this lack of the beryllium and lithium and I believe boron.
Yeah. And astronomy. Astronomy is one of my hobbies, and I knew that from astronomy, and I knew that the reason that the astronomers give why that is so, that's a fabrication. Like so many things are fabrications. To talk about nuclei, just a simple thing of nuclei, and the story of hydrogen. Hydrogen, of course, if you would cool that to absolute zero, we know we still have the 0-point energy then. But nobody understands, of course, why, because if you know the law of Boltzmann will tell you that the kinetic energy, which is needed according to the Bohr theory, to keep the electron in its orbit, to counter, of course, the attractive force, E squared over R squared, from the nucleus, or Q1 or Q2 over R squared, the law of Coulomb.
Sure.
And of course that doesn't work. The whole model, Mr. Bohr was a wonderful person and he got the Nobel Prize, but the whole model is totally wrong. I don't care what, they can send any number of Nobel Prize winners over here, and I will show them why it's wrong, and give you plenty of demonstrations why it's wrong.
Oh, yeah.
And,
it also sounds like one of the things that you've been able to excel at, that Blacklight Power, and again, I should apologize for not being highly familiar with their work, but it sounds like you focused a lot on the electron's ground state, in addition to the hydrogen atom itself.
That's the main cake. Then I noticed, Tim, this also came by doing all these things. I don't theorize all that much. My work is actual work with the hands and the tools, every day long days, lots of instruments around, oscilloscopes hooked up everywhere. The thing is this, what we found is, we started doing different electrodes, different cathodes, and then some new elements appeared. Suddenly we said, well, how the hell is that possible, of course, but new elements appeared that were never anywhere, and we had it tested. Of course, we got a university very close, and electron microscopy and all these things, and spectrum analysis and all. Then we found out that the roles of electrons is enormous in these processes. We came gradually, of course, also already with the fractional hydrogen, we came into vortex procedures in the plasma. Can I tell you a little bit about that? That could be interesting to the people.
Sure. Actually, that brings me to
I've been told by professors who know them very much, who wrote also many books, that I couldn't send positively charged particles away from a cathode to an anode, and I can tell you I can. I think you can come see it any day. There are all sorts of ways that fusion can take place at much lower temperatures. Eugene Mallove was, of course, the great man of cold fusion, and I might talk also about cold. I always talk to him about lukewarm fusion. Thermonuclear makes absolutely no sense, but we have fusion processes whereby, say, we run only like temperature temperatures like 400 or 500 degrees centigrade. I'm just saying there's a little range here. But the trick is, if you have a fast vortex, a fast rotating vortex, whereby, and you don't have to have that much voltage even, you use very little power, you must have an angle, for instance, a helical angle in that vortex of, say, less than 8 degrees. And if you have, for instance, I'm going to illustrate you something that people can understand. Say I have 10 centimeter distance between a cathode and an anode, and the vortex eye wall, really what you see is the eye wall. The center, of course, is nothing to be seen, but the eye wall you see. If that's a centimeter in diameter, then the path that the charged particles describe is 720 times longer than the distance between the cathode and the anode. And there's also an English researcher found this, actually before me, but in a totally different area, nothing to do with energy generations from plasmas. If you have charged particles of equal charge paralleling each other in a vortex, in a very fast flow, you have the same thing as like electrons traveling through copper wires, say on telephone poles, and you put DC through the wires, and the wires will attract each other if you send the electrons, in the same direction. You probably know that.
Sure.
So the same thing is happening in these vortexes, and equally charged particles will have a greater Lorentz force attraction than the charges would actually push it apart. But we visually can see the points of fusion. You see it light up in the vortex. Just a little flashes coming up and all, and you see it immediately on the meter. The power increases, instantly.
Well, to stop you for just a sec, I'd like to,
sure.
for the audience's sake,
yeah.
We have a mutual acquaintance who he was the person who really got me excited about your work. He tested one of your devices for several months, and he described it using a cathode and an anode, and it had the light metal nuclei that you've described in there. And apparently, when this plasma vortex forms, these atoms erode off of, I guess, the cathode, but his description was exactly what you'd said. They enter the vortex and spiral closer to each other towards this anode, and he saw flashes of light denoted by a jump in the oscilloscope that indicated a true nuclear fusion process.
Right. Well, actually, we have that process, Tim, to take the guesswork out of everything. We had it twice certified by an independent laboratory, a big one too here in this country. And we ran it the first times when we were still in the learning curve. We ran it 3 times more energy out than in. And then the second time we ran 6/1. And right now we can run probably 10 or 15/1. I'm not even running that process all that much, because the fun of developing is now basically mature. Because I can just push a button and the thing will run for the whole day. I don't even have to look at it.
Well, out of curiosity, do you know if this process is aneutronic, and does it produce any radioactive emissions?
It's aneutronic. You see, fusion is nearly always aneutronic. Anytime that nuclear energy being discussed by the public, everybody is scared. No wonder. Fission always is breaking up things and everything flies around. And fusion sucks things up. Components come together in fusion. That was also certified that there is no harmful radiation. I can give you the reports if you want to. And there are neither any neutrons flying around. We tested that all out. But the thing is, what we found with the fractional hydrogen work, which is very important technology and still is, even while we do zero-point energy, you bring up a point here that, we invent things actually that we outdate our own still great inventions. That is true to a certain extent, but not fully, because CPE is quite expensive because of the lower energy densities at this point.
Sure.
But may I tell you about a little bit more about the plasma fusion?
Oh, absolutely.
There are a ton of reactions possible. I have written these down, but I cannot develop that much. We spend a lot of time, of course, finding all these things. But basically, all of them will have one of these elements, beryllium or lithium or boron. All of them. Eugene Mallove had a lot of people, over time. You can see that in the Infinite Energy magazine issues. A lot of people discovered things, but nobody could really, or didn't have either the funding or whatever, or the knowledge, to bring it really to fruition.
Yeah.
But always these reactions need an extra electron. And very strange, the electrons play a major role. Now, the typical thing about a vortex is this. You're talking about in the material realm, the vortex, we see all the particles fly around, but in the non-material background, actually, or foreground, or center ground, when you talk about a vortex, we have a lower density of the ether of space. And electrons drift from low density to high density due to their own individual energy needs for fluid energy. So the electrons play a very big role in the plasma vortex fusion. But anytime, if you want to fuse things without a vortex, it will never work. You're never going to run over unity. As soon as you got a vortex appearing, you will run over unity.
Oh, so that's really the key, as well as injecting
It's a
electrons.
very big key. But the vortex always forms instantly. And why, Tim? Let me explain you why. An electron always spirals. An electron will not only a free electron I'm talking about, not only in a matrix of a metal. No, in free space an electron spirals too. And the reason is the constitution of an electron being two vortex rings that roll against each other shows not only a single axis of rotation, which is the one that physics teaches. No, there is a second axis of rotation through the slit between the two vortex, the vortex rings between the two donors. There is a second one. Now there is a precession is the second one, but the second one is also responsible for an effect fluid dynamically. It's called the Magnus effect. These two motions allow each for a sine wave in two planes that are perpendicular upon each other, and they're 90 degrees out of phase. This is all in my book. Everybody can learn and study this in the book. That's been proven too. The electron is motion is composed out of two sine waves 90 degrees out of phase with each other, and if you put that together, you'll see stereometrically you get a spiral motion. And that spiral motion is very important, and we have learned, by learning the effects of the spiral motion, of course, introduces right away that the vortex occurs in the plasma.
Well, I'd like to back up for just a second.
Sure, you go ahead.
The fluid dynamics description is interesting. It reminds me of another scientist named Ferris Williams, Dr. Ferris Williams, who has been working on something similar. Now, in his case, he's actually been able to apply similar principles of fluid dynamics to predict particle masses. And I'm wondering if you've had any predictions from your theories to confirm existing measurements.
Fully so. I make very much distinction between mass, like we've been told, mass as being something tangible. Now, I have fluid dynamic energy levels for every particle entity. Every vortex entity has a certain energy at rest, and it has higher energies in motion and all. And as you probably know, Tim, you know more about this than probably the average person. A single vortex ring looks like a donut, of course. In space, constitutes a neutrino, and it becomes an antineutrino if the thing would flip over 180 degrees, whereby the jet of the center would come opposite its direction of motion, and then it stops like on a dime, really. And some very special things happen then, but it's not part of this here, I believe. Then there are four types of particles that consist out of two vortex rings. The electron, and the proton, the best. The positron and the antiproton are the other two. Now, nobody can explain why there are protons, because we know that sufficient energy in radiation and all, in waves of high energy, can produce particle pairs. This is, I'm just talking about things that many people know, of course.
Sure.
It's called photon decay. You follow me?
Yeah.
The positron electron can, in the fluid, and it can be fluid dynamically exactly shown, grow out to a proton right quick. It's typical that the vortex rings of the electron and the proton, the rings themselves do not differ very much in size. Like the hole through the donut of a proton is √3 times the diameter of the ring, and with an electron it's much less. The electron takes much less energy in and is voracious to get energy. It actually shrinks upon itself. It's very unusual. Of all the particles is the electron itself. Typically a technology that came forth out of this, Tim, that we didn't even discuss yet. We have achieved superconductivity in copper, aluminum, and many metals, virtually superconductivity at room temperature, without putting any energy into it.
Well, I'd actually like to build off that to ask you another question, because
sure.
the individual, again, the acquaintance that we had who had tested your device, had also described what he called a cold current device that actually inverted the normal thermoelectric properties of a circuit, so that when you run a current through something, instead of running hot, it runs equally cold. Is that something that you've constructed?
That's well, I'm still going to do a patent on that matter too. We have a device that does that. If you start, everything changes. If I would push an electron, and we're going into a little bit more exotics now. Is that all right, Tim?
Oh, yeah.
I push an electron through a very thin film. If the size, the thickness of the film is less than the diameter of the spiral that the free electron normally would describe in a matrix of the same metal, you follow me?
Yeah.
Then the second sine wave motion is impossible. And what happens is we have one sine wave motion of the electron left over. Now, if you see the road of an electron through a free electron just that travels through a matrix, if you see that, how many points it has that it has to cross what do you call energy thresholds, between nuclei, or when you see it with a single motion, then you see that single sine wave motion, then you see that the number of encounters of all this is much less. That means the ohmic resistance goes very much lower. Now, this has been confirmed by other researchers too, by the way, but these researchers didn't see the importance towards energy systems. So what I do here is this. I have one process. I'm going to look at that. As a matter of fact, it's a little distant from me here. And I have very thin films. And then when the ohmic resistance is gone, then the ether wind is suddenly strong enough, if you have a strong permanent magnetic field over it, to push the electrons to one side, so you get electric current for free.
Okay.
And stuff like that has come all up out of this. All these kinds of principles are being used here. That's how CPE gradually came into being. Okay? The CPE research came into being here. Let me say that CPE has always been there.
Yeah. Well, and I guess that is kind of, moving forward in our review, that is one of your great accomplishments also, is, again, an array of energies that tap into zero-point energy to turn it into useful electrical work. Can you describe that a little bit for us?
Well, I can tell you, with all these things being tried, I have found also that gravitation plays a big role in all of this too. If I have, for instance, a film like that, perpendicular on the gravitational inflow. By the way, gravitation is also no force, just like the strong force in the nucleus doesn't exist, neither the weak interaction. Those are all contrivances from the 1930s and all, but none of that exists. Gravitation, as we feel that to our feet, is the resistance of the Earth keeping us in the stream of the ether fluid that goes towards the center of the Earth, in the direction of the center of the Earth. That's all it is. The velocity of the incoming gravitational flow is 1,821 meters per second at the surface of the Earth. And we'll soon be able to use that too to get energy direct out of that. It's still a little bit tricky, but it does work to a certain extent, because if I take films and I put a film on an edge, like a knife edge in the ether wind, from space, well, you have no energy effect from that sheet, and if you put it perpendicular, you do have that. And I call that action polarization of electrons. Again, electrons at that point lose one of the sine wave motion components. And their ohmic resistance virtually disappears.
Okay.
Giving you a lot of secrets here, Tim.
1,821 meters per second isn't actually that fast. I'm wondering, is this ether wind comparable to I guess Einstein's fabric of time and space in some ways?
Yeah, all of that, of course, space-time curvature calculations are part of this any second. You know that. That's part of it. Anyway, what I would say, too, Tim, in this, for people, if they're interested, the best thing, because you talk about, to me, about books and all that I wrote, several of these books are very heavy. Now, even the introductory book to all of this, that's what I would recommend to everybody, that they start learning the so-called primary physics, which is the underlying physics of the non-seen realm, okay, the non-material realm. Now, there is such a thing as a non-material realm because regular radiation has no mass either. You follow me?
Sure.
Part of it, too. So, the ether physics I'm talking about, we have discovered all the formulations. Every major physics law, as it's being taught right now, comes forth out of that. And you're right about Ferris-Williams here. I have taken all these laws that we have in just simple laws like E equals mc squared, things like MC is m0 divided by the root out of 1 minus v squared over c squared, stuff like that. That's all fluid dynamics too. It's all fluid dynamically easy to do. Like for instance, light waves, electromagnetic waves, curving in a space-time curvature field. All these things. It's all in my book. The book requires that you have at least, actually, a little bit of a graduate level of understanding of math and physics.
Well, now your book, for people interested in learning about this theory, you mentioned the primer book, which should be available online at www.amdgscientific.com. Yeah. And I'm wondering if you could tell us a little bit about the price and what it contains and whether people can use it to build devices straight from the book.
Building devices from the book will be very difficult. That's scientifically fairly heavy. Still is fairly heavy scientifically for most people. Okay, it's not a book to make equipment with. No,
sure,
not that. But you will understand the relationship between factors. The book will tell you about the dependency of, for instance, the speed of light is what we call. Actually, I call that the maximum velocity of communication of elementary particles. That's the kind of term I use for that. Now, that's totally dependent on the density of the ether. Everywhere, when you have, for instance, a vortex in the ether, right in these little reactors that we got here, at the eye wall, the density of space is 2/3 that it is in the surrounding area. As regular fluid dynamic physics tells that. So that has led also to some other things, Tim, and that was your kind of work with the lifters and all. Artificial gravitation and all can be achieved with all of these methods too. Coming from different angles to it.
Yeah. Now the book itself costs around, it's in the $70 to $80 range, isn't it?
Yeah, but that's with a nice cover and all. That is what do you call it, hardbound. But the regular thing will sell for $35 or so.
Sure. Well, and that's something we'll put a link up to from the website as well.
Yeah.
Now, in addition to this book, you're also working on an upcoming book, as I understand it.
I have several, Tim. Let me tell you about it, and I want the public can know that.
Well,
I could publish quite a bit more. We have actually. Let me give you the titles here. The introduction into ether physics. Let me just say that that's the main book that people need to have first. Then there is a part 2 that's called micro phenomena, and part 3 macro phenomena. The micro phenomena is a very large book. It's very extensive. It goes into all nuclear structures and all of every element, every isotope of element, and why it is like that, and what we can derive from that. And by that knowledge, of course, I found a lot of other things. But that book, we will publish the first half of it, and the rest I do not want to publish it for simple reasons. I want to see how everything develops first in the nation, as far as these things are all the underpinnings of many of the black box programs and all of that.
Yeah, well, in terms of, now you'd mentioned atomic geometry, and I'd like to touch on that,
Sure.
because one of the things that you've described in the past is your theory being able to predict the properties of a chemical, for instance, a liquid or a solid, based on the geometry of the atom.
Absolutely sure. Listen, the time of the alchemists is coming back too. You see, like, for instance, a precious metal like gold. You know, I mean, it's always, people will laugh at that if you tell them, you know, with plasma fusion, I would be able to make the element gold. I'm not saying that's economical. I think it's a lot cheaper than gold is costing right now, but I have no time to try it even. The energy generating processes are much more of my interest.
Yeah.
So, we need to help mankind here, because we're running into a few problems fairly soon, I believe, in the Middle East. So the push is with the energy generating processes to get them ready, you know, for commercialization. That's basically what it is. But all the elements are formed out of other elements. Elements like magnesium and aluminum are really also building blocks. They fuse real easy with each other, with other things and all of that. And you asked me something about noble gases. And noble gases, of course, you know, cannot do anything. You know, we have learned in physics they're totally inert. But that is the case of chemically being inert. It's fine. But if one would know the nuclei, how they look like, the nucleus of argon, for instance, is a tetrahedral. So a pyramid with 4 planes, not a 5-plane pyramid like the ones we have with one in Egypt and all, but a 4-plane. And for instance, the element krypton can be formed from that by means of a physics mechanism called the double neutron binding. Now, I didn't do the name, but I been taught by some other people a few things that noticed that nature could have done it like that. Now, let me tell you, we have proof for all of this. I'm going to also a bad occasion for alternative energy people. And Eugene Mallove described that again in detail in some of these issues of Infinite Energy magazine of maybe 4 or 5 years ago, or maybe longer than that. I have every issue here, I hope. But there was a man in California, and that was PEP, and the PEP engine that ran also on noble gases, and he had a little mix of noble gases.
You know, it's interesting that you should mention that. I'm actually compressing a video for that this evening, hopefully, so that'll be something we'll be putting up on the website
Well,
as well.
you can ask me about that, because I know every bit of why it works and how it works and all of that.
Well,
I applied all for patents for that.
So you're fusing argon into krypton, and another thing that you've done, and again, this is back to the plasmavolt, is, as I understand it, you've produced several grams of potassium-40, which is a rare but relatively inert isotope.
Yeah, we can do that. We can produce it. You give me an order, and I'll produce it for you.
Yeah, now, and as I understand it, potassium-40, the only other way that's typically produced is in a very hot mixture of ingredients that come out of a breeder reactor.
Sure.
So that's...
We make 1419 here, yeah. I can show it to you.
Oh, potassium-4019, okay. Yeah, so the proof really is in the pudding with your invention.
Oh, yeah,
in terms
but with all the other reactions, too, there are many more, Tim, that I haven't even told you about, you know. There are many, many more. That was that gentleman who has been witness of all of that, knew that. But you see, if I take, that's with the elements beryllium and magnesium, if I take beryllium and aluminum, I produce sulfur, and things like that. And with other elements, that's how actually in the universe things build up too. That's how it went.
Sure.
I'm finally finding out how elements were formed. Precious metals are very close to a couple of gases that are dirt cheap, and it needs a metal with it. And if you can fuse all of it together, if you're capable of doing it in a reactor system like this, with electron discharges through the plasma, you could possibly make gold or platinum or whatever. I wouldn't know how to make gold anyway.
Well, you know, one thing that's becoming increasingly, I guess, of interest to the scientific community is not necessarily just new elements, but new molecular structures for existing elements. And I guess the two examples that really caught my eye were, the first is a company has developed an electroplating process where they're actually able to use, I guess it's almost like a beam of plasma to lay down a coating of diamond on top of plastic.
Yeah.
You know, and
that process does exist. Yeah.
Yeah. The other I think is a lot of the nanotubes and nanomaterials that are out there, which again use carbon. Can you build complex molecules with your technology?
Technology here, of course, vapor deposition is also a concept, in all these things, to get layers of like 1 atom thick or 5 atoms thick, of material on something else. But some of those technologies that we have, we can make all sorts of isotopes here.
Oh, okay.
All sorts of isotopes can be made. Again, we are not concentrating in that area right now because the energy generation processes are on the menu. That's the main cake.
Now, the two big ones that you've described, at least in the past few days, have been an energy conversion system. Well, the first one is to power a laptop by pushing electrons again across a membrane, and the second is, I guess, a conversion system for an automobile. And both of these use zero-point energy. Can you describe it a little bit for us?
The details of the membrane technology, that I'm not going to discuss yet here on the phone. We are working very hard on that, and it's very promising. And I can tell you, it's absolutely possible that these units could work. For instance, the energy density is now up, I can tell you, by a factor 10,000 in 1 year's time. But it's all hard work and research. I just found something else again that might also be in favor of even better results. Now, the materials that are being used, in this, I want to discuss that a little bit. That's not very cheap material. 1 or 2 rare earth metals might be involved. That's why I was telling you the cost of, say, creating 100 watt, totally CPE powered, continuous power, still costs very much money. Okay, like some of these fusion processes, typically the process like fusing argon into krypton, if that could be commercialized, and I know it can, that would cost virtually nothing. 1 charge would last for 10 years, and that 1 charge costs 1 penny, because a whole small bottle of argon you can go buy it for $20.
Sure.
See, stuff like that. So you got to see the economics of all of this, but the zero-point energy applications are the great ones. That's the final answer.
Well, and that brings us to the idea of, again, tremendous energy density in fusion technology, and one of the advantages there is that this tiny little cathode with the light metal nuclei in it can really last for several years to power the 400 or 500 watt device, right?
Oh, sure you can. Sure. I'm still using the same cathode as I used many years ago. Never had to change it yet.
Well, out of curiosity, you'd mentioned a 6-to-1 gain ratio, I guess, 6-to-1 over unity.
Energy gain ratio, yeah.
Energy gain, yeah. And I guess that wouldn't be over unity because the energy is coming from the fusion. But how many watts overall have you been able to achieve in terms of output?
You can systems like that. We run like 100 watt, 200 watt. And I have a real big reactor. I have not started it lately because of the concentration of certain things that we want to go commercial with. It could easily be made 100 kilowatt units. It wouldn't be too hard. You would have multiple vortexes. Now you cannot just put vortexes just together like you stack steel or anything like that. The flows in these things you have to have separate tubing separations in a big reactor and all, where the vortexes are. I had to learn that, of course, the hard way too.
Sure.
But all these technologies could be working very well for us. Now, you came back to that again, to the plasma fusion. Let me tell you the parameters of that a little bit. A unit like that, with 6 times over 1, it's not yet very hot. You can run the other fusion processes with argon very hot, very, very hot. You get the glass will go. But the thing is this: the two light elements that are being used in the cathode, they have a nuclear transmutation which not only produces K4019. No, the fun is that produces hydrogen. So it's not really using it's using a teeny bit of hydrogen in the reaction. There's one electron, a little bit, it's being used in the reaction, but it produces a lot more. So for one hydrogen atom that's being used, we get two back. So actually the whole system produces some hydrogen continually too. And that you could put that through a fuel cell.
Oh, I see.
The total production of power is still a good bit higher, but that can be used too. But anyway, that's just one reaction, but there are many more possible, and I believe that, of course, many people should be involved in this work in developing that. I do not have the financial capability of pushing 5 or 6 programs at one time. I push about 2 or 3 at a time. But this area is still wide open. Many companies would be very surprised what plasma fusion could do.
Yeah. Well, one of the other projects that seems like it's, again, not a priority for you right now, but has been remarkable, at least to hear about, is you've done some work talking about the effects of gravity on an object by applying an electromagnetic field 180 degrees out of phase with the resonant gravitational waves inside of that
particular matrix, yeah.
Yeah.
That can be done. Now, that was done by Francis de Aquino in Brazil. And you know what happened to him? He got house arrest from, I don't know what kind of an authority.
Oh, the Brazilian government.
Right,
yeah.
Right. We know that from a lot of our friends, okay? But anyway, it is a very wonderful system, but that system still costs money, too. It costs energy. You see, the 0 point we have now, Tim, how it went here, the development, we first found these film processes. They still have to have an input, too. In other words, you still need a little bit of electricity, either from a battery or from the wall, and then you produce more electricity. So we wanted to be independent. So it took a long time to come to the point whereby we didn't need anything. So self-starting processes. So we do have a magnetic power cell. It's a major invention. That power cell, you can set it in a cage of Faraday anywhere you want to. Here in any other location in the universe, that thing will produce electricity without a shadow of a doubt.
Okay.
That's the absolute final proof. I made a special setup that if I get challenged, because there are still people in universities, even at MIT, they are told, like a mutual friend of ours, Professor Ted Loader, they told him, we will not accept the existence of zero-point energy, and if we saw it, we would still deny it. Now, that's how crazy we are.
Well,
but due to that fact, that statement being made, I made a unit, that if anybody says that in the scientific community or the American Physical Society, I can take them to court and laugh at them, okay? But everybody will see it that it does work.
Sure. Now, one organization that has been starting to change some of these, I guess you'd call it negative opinions towards breakthrough in alternative science, has been the STAFE conference. And I think that there are more to come, but for the time being, again, that's the University of New Mexico's Space Technology Applications International Forum. I'm wondering if you'd thought about ever publishing for something like that, given...
Well, we can publish certain things. I mean, if if the circumstances politically in the country allow this, to do this, that acceptance is coming, that also other things did work all the time, of course. The things that would happen, these tremendous problems, that Gene has had to face in all of his life, anywhere from Ponce and Fleischmann, you remember, and further towards this particular time. Yeah, these processes work too, but it doesn't necessarily mean that they're economically practical. You see what I'm talking about?
Oh, yeah, well, and you've definitely refined them. The reason I mentioned STAFE was one of the papers this year presented by Dr. Arie DeGeus, and it just kind of strikes a chord with what you've been describing. He published a paper about forcing hydrogen through a Casimir plate system, taking it down below its ground potential state, and then extracting energy from that as electrical power. So it seems
well,
like this would be right in line with what you're already doing.
That is in line what we have done too, yeah. But different people do different things. There's lots of things going on in Germany. There was as a matter of fact, I'm supposed to get information any minute here over the computer. There was a little conference in Germany, I think yesterday. On Monday, that was yesterday, whereby a cell is being shown, a very small cell, an IC or whatever, which magnifies power, apparently with absorption of CPE2, and so on. So there are many places now where there's work being done. I understand that in Turkey, a person has developed a motor which runs over Unity, and it is in Munich at the patent office right now. That's this is all hearsay. What I'm saying, folks, right now, I get that from other people in Europe over the phone and in writings and all. So I have not witnessed that. The only thing I can stand for is my own place and what we have done here. But a lot of people are working hard, and I tell you what, within 1 year, we'll look at a couple of new things in the world.
Yeah, absolutely. Yeah. Well, we're almost out of time for today, but again, I should direct people to your website at www.amdgscientific.com. And again, I'd like to say thanks, Arie, for your time, and I look forward to hopefully more interviews in the future on your new projects.
Oh yeah. There's many more things, we could go in, but that will take a long evening to go in several of these other things. But if folks want to learn, people who are very interested to learn anything, I would recommend very much to get a hold of the underpinnings. Those have all been shown and being read by many professors in physics. They all say it's a wonderful book, and they all say and the math in it is also correct. Nobody has to worry about the correctness of the work. I got a lot of it. The original education, let me say that still, comes a lot from scientists like Max Planck and like Winterberg in Germany, a couple more German scientists and all, that I picked up lots of information over time.
Sure. Well, thanks again for your time, and have a nice evening.
Yeah, okay.